Okay, the connective tissue has certain categories. It can either be loose or dense, and loose is going to have more ground substance. Remember, that is the portion of connective tissue that gives it its fluidity. So it's going to have more ground substance and fewer fibers. And that fluidity, don't necessarily think of very fluid, but can be more fluid. So more of those sticky proteins and water, and fewer fibers. Think of fat tissue. Or dense connective, and just like the words say, this is going to have more collagen, more elastin, fibers, less ground substance. The specialized cells that can be embedded into connective tissue and henceforth give us all the different types that we can end up with. First one is fibroblasts. These are the most abundant cells. And what happens here is these are specialized cells that secrete proteins, and the cellular cement that holds connective tissue, say, attached. We talked about the basement membrane. These would be the types of cells that secrete the protein that causes that attachment to the epithelial cell, and any other type of tissue they'll attach to, whether it be muscle tissue or nervous tissue. Fibrocytes, these are cells that are the fixer cells. So if your collagen gets damaged due to UV rays, fibrocytes will work to fix that. Unfortunately, one of the things that happens as we age is these become less productive and you have fewer of them. So the collagen doesn't get fixed as well. The fibers don't get fixed as well. And you also have this in a tendon tear or a ligament tear. These are going to be the fibers that are going to fix. These are going to be the cells that are going to fix those fibers. Adipose cells, we've talked about these quite a bit already, adipocytes. Mesenchymal cells, these are stem cells that can differentiate into many different types. Fibroblast or macrophages. So fibroblasts, remember, that's the cement that holds connective tissue to other types of tissue. Macrophages, these are the generalized eater cells. They're large and amoeba-like, and what they can do is they can go and engulf pathogens and neutralize them. They can either be fixed in tissue, like the lung tissue, or they can actually, in all the tissues you find, in most tissues you find macrophages fixed, or they can migrate to an area where they're particularly needed, which is a nice feature of macrophages, because they're not necessarily selective. As long as they don't get overwhelmed and they engulf, they can engulf and neutralize. Mast cells are specialized cells that release histamine and heparin, and what this does is causes fluid to come to the area, and if fluid can come to an area that's been injured, that means specialized cells can come to that area too and have the fluidity to do the work they need to do. Basophils basophils are a type of leukocyte, aka white blood cell. And they can come to the area. They can also release histamine and heparin. Lymphocytes are the general killer cells of the lymphatic system, of the immune system, and those can be in connective tissue, or they can come to the site of an injury. Macrophages, like microphages, similar to macrophages, they respond after the macrophages get there, after the mast cells get there, and they are more specialized with regard to the job they do in terms of fighting off a pathogen. An example are neutrophils and eosinophils, which are both white blood cells. And then melanocytes, we talked about these already. These protect us from UV light. by synthesizing the brown pigment. It also, melanocytes are always synthesizing brown pigment to a certain degree, but they have the capacity to act even more so in the presence of UV light. In terms of fibers, you have collagen, which probably you can relate to collagen fibers. They're long, straight, unbranched, very strong, have great tensile strength, very flexible in one direction. So they resist force in one direction. We think of tendons and ligaments made up of collagen fibers. And also you have collagen in your dermis underneath the stratified squamous of the epidermis of the skin. Reticular fibers, these aren't quite as regularly organized, so they're a network of fibers. They're also strong, but they can resist force in many directions. And what they'll do is create sheaths around an organ so that you have this strength. You have like a strong blanket around an organ that will have specialized cells in it, whatever those specialized cells are doing. I think of the spleen or think of the kidney, where you have these specialized cells and this sheath around it. Elastin fibers, these, just like the name says, have the ability to stretch and then return to their original length or shape. They're wavy, branched, and so you have elastin fibers in your dermis also, as well as the ligaments of the vertebrae that give you the ability to have the subtle movements you have in your vertebral column. And then ground substance, which we've talked about already, is this fluid, viscous fluid that fills the spaces between the cells. And basically even protects to slow down pathogens so that they can't move through the area so fast. Here's this picture again. You can kind of, maybe it makes more sense to you in the things that you're seeing now. Again, this picture comes straight from your book. This is a generic cell that isn't seen, but you see all of the, you see all the key players of connective tissue here. Types of connective tissue, and so these all come from your book. It's really interesting to see them, associate them with an area, so I do like the way that your book presents these. So you have your lungs, you can see that image. Areolar connective tissue, it tends to be irregular or open or loose. What you have are these cells embedded in. So you have mast cells, because we need those in our lung tissue, collagen fibers for strength, you have your fibrocytes, and you also have your elastin fibers. You will have you have this in the dermis of the skin, covered by the epithelial lining of the in the digestive, respiratory, and urinary tracts between muscles and joints, blood vessels and nerves. You have this type of tissue. Cushing's organs provides support and permits independent movement. So areolar tissue, and you can, and the pictures are worth 1,000 words from me anyway. And then adipose, I think we've talked about this enough. Adipose tissue, this is where you find it. And reticular tissue, I believe I talked about the spleen, also the liver, lymph nodes. What this does, this is the three-dimensional, can stretch in many directions type tissue that's going to be around the specialized cells that define that organ as itself. Now a liver is not made up of reticular tissue. It is surrounded by this particular tissue. And also the reticular tissue will be interspersed among the hepatocytes. Dense regular, sorry about the cutoff, dense regular connective tissue. You do see it at the top of the picture. Just like the name says, lots of fibers, it's dense. Those fibers are laid down in a parallel fashion, and it is connective tissue. What you have is this kind of tissue makes up tendons that attach muscles to bones, and also makes up ligaments. The difference between a ligament and a tendon is that the tendon is going to have a few more elastin fibers, so a few more of the elastic fibers. Epineurosis, these are sheets of flat attachments for over flat areas like your abdominal area. And although I'm not saying that muscles are connective tissue, what you have is this dense, regular connective tissue as the fascia that is marbled in amongst those muscle cells, the muscle tissue. Dense, irregular, and this is your that you have collagen fibers in the layers of the skin around cartilage. So dense, irregular, you have a little bit more stretch in various directions. So dense, regular, you have stretch basically in one direction, or you have strength in one direction. Dense, irregular, you have strength in multiple forces, and that you find that in the bladder, also the dermis. Muscle sheaths where you need to have more than one area that is going to have force, as opposed to, say, a muscle. All the muscle does is pulls. So you have that muscle moving in only one direction. So that dense, regular is okay. It's very strong, but just in one direction. This is strong in multiple directions. And then elastin tissue, as we talked about, between the vertebrae, where you have quite a bit of give. And there is quite a bit of subtlety of movement of the back between the vertebral bones. And this also acts as a shock absorber. Fluid connective tissue, this is another type. We think of blood and lymph, and I've kind of already talked about this a little bit. You have the plasma, which is the watery matrix, and embedded in that plasma you have very few fibers, but you do have specialized cells, red blood cells, white blood cells, and platelets. The fluid is considered extracellular, so outside of these formed elements or these cells, and that's plasma, interstitial fluid, and then lymph fluid. Lymph fluid has its own system, the lymphatic system, but it eventually dumps into the cardiovascular system. And then connective tissue that supports soft tissue and body weight, such as cartilage, bone, and cartilage is a gel-type substance, and it works to protect where there are pain receptors and as a shock absorber. All you have to think about is if, unfortunately, you're somebody who has lost the cartilage off your end of your long bones, and anytime there's a joint, you have articular cartilage at the end of the long bones, and that definitely absorbs shock and protection from pain. If it's gone, you have pain, unfortunately, every time you move that joint. Bone is calcified connective tissue. You have calcium salts and minerals that come in and make bone the strong tissue it is. And remember, we will talk about this material again when we talk about the skeletal system. With regard to cartilage, you have ground substance and chondrocytes. No blood vessels to cartilage. It's avascular. And I will pick this up on the next one.